7.2, margin of error. Let me jump over to my other screen. Oh, hello. All right, so here we're going to calculate our margin of error for section 7.2. All right, so here I'll remind people we are estimating population means. The confidence interval is X bar plus or minus my margin of error. That margin of error takes a slightly different form than it does in 7.1. We use the t distribution. So we've got a critical value that's t alpha over 2 times the standard deviation divided by the square root of my sample size. Here again, I'm going to point out that the t alpha over 2 critical value S divided by the square root of your sample size. That is your sample data. So very much like the previous section, we have a mix of critical values and sample data. So again, we're going to use our TI-84. If you have access to your program, we're going to use the T inverse 83 program. If you do not have access to that program anymore, that's all right. We will use the inverse T program, which is built directly into your calculator. The process, very similar to what we saw in the previous section. We're going to go ahead and ID the data. That'll give us this stuff here. I'll go ahead and locate the critical value, and that'll give me the T alpha over 2. I will partake of the formula for the margin of error and round appropriately, usually to whatever your X bar is. So that's going to be the process. So let's see. We're going to take a look at a couple of examples. And again, the process is very similar to what we saw in the previous section. So if I use the T inverse 83 program, my example here, we'll use a mean of 56.1, a standard deviation of 4.9, and a sample size of 41. We're going to go ahead and construct the 90% confidence interval. And very much like we did previously, our heavy-duty work is going to be finding those critical values. I don't necessarily need to find the standard deviation. It's right there. I don't necessarily need to find the sample size. It's right there. So really important thing is the T alpha over 2 values. So here again, this time I've got the T distribution. And again, I am looking for 2 distinct critical values. There'll be one on the left and one on the right. Very much like we've done before, I will note that the area is going to be given to us by the level of confidence, 10%. And again, the area alpha over 2 in either case. Now, I'm looking for 2 critical values. What I do need is the degree of freedom. That's equal to n minus 1, or in this case, 41 minus 1. I'm now ready for my calculator. Turn on my calculator, under Program, I find my t inverse 83. And it'll work very much like the inverse normal program. I'll select two equal tails, but this time I get a question. What's my degree of freedom? Well, 41 minus 1, I can just plug in 40, or I can make the calculator do the subtraction. And total area of the two tails, there's my alpha, 0.10. I'm going to get two values, a positive and a negative, plus or minus 1.684. Over here, 1.684. Now I'm ready for the formula. So my margin of error E is equal to my critical value, 1.684, times 4.9 all over the square root of 41. Your calculator loves this stuff. That's why it was born. So we'll bring the calculator over and let's see, 1.684 times upstairs 4.9 divided by, pick up the square root, 41 goes in, just hit enter, and you're good to go. So 1.288 and change, 1.3, same rounding as X bar and S. So my margin of error, 1.3. And that concludes this example as far as finding the margin of error. So if I got my t inverse 83, I've now found my margin of error. I can now complete the confidence interval. I know that's not the question, but we've done all the hard work. So my confidence interval is 56.1 plus or minus 1.3. And that there is really truly how the big boys and girls like to write their confidence intervals. Point estimate plus or minus margin of error. But suppose you don't have your programs. Well, let's take a look at another example. This time, I'm going to use the inverse t tool. And for my example here, X bar, 42.3, S, 7.2, sample size, where are you? We're going to use 39. My confidence level, we're going to construct the 99% confidence interval. Here again, I've got all my important sample data right there, all set for my formula for my confidence interval. The only thing I do not have is the critical value. So here again, I'm going to remind people that the picture is really a means to an end. I've got a critical value on the left. I've got a critical value on the right. So the tool inverse T works very much like the other tool we discussed previously. I have to provide area that is strictly measured from the far left in. So I will be providing in the inverse T tool, I will provide area and the degree of freedom. Then I will rely on symmetry to get me the rest of the way there. Here's my calculator. Second, and again, I pick up the distribution tool. I find the inverse T. And here again, this is the time I'm going to want to actually use the alpha over 2. So the area that I will use is 0.01 divided by 2. And that's the area of the left tail. 0.01 divided by 2. I need a comma and then the degree of freedom. 39 minus 1 goes into play right there. Close them up. And my calculator thinks for a moment and gives me a negative 2.711 and change. I like 3 decimal places, negative 2.712. How do I get the other point there? Symmetry. Symmetric distribution. So if I know this point here, I know that point there. We are now ready for the formula. So my margin of error is equal to the 2.712 times 7.2 over the square root of 39. And I'll take one decimal place there. So 2.712 times 7.2 divided by the square root of 39. Blow on it once for luck. And I get a 3.12 and change, or 3.1 to one decimal place. All right, so if I'm going to use my inverse t built-in distribution, my margin of error here is 3.1. It's not part of the problem, but again, I'll finish up with the confidence interval. I've got the mean 42.3 plus or minus 3.1. There is your confidence interval for this particular margin of error. You've seen a couple of examples now. Let me know how they work. Thank you.